What's up, people, and welcome to the second part of this tutorial about generating random numbers. So in this tutorial we're going to dive into Excel and see how we can model the problem here in order to find good values for the standard deviation and the mean. Alright, so let's say that you have a scenario where you have like a web shop or e-commerce store, and you want to apply some randomness to your pricing for some reason. And maybe you don't want to have like totally random pricing. You want to have some boundaries on it, and maybe, just maybe, you want to, use a normal distribution like this in order to say that you have the original price here, like the mean, and we can generate it up and down a little bit according to this bell shape. So you wouldn't get too crazy with the pricing, but still you would have some cases where you would be doing these extremes here out in the bell shape, right? So that is the scenario that we're gonna model, right? So how would we find good values for this? You would start by saying, you know what, the thing that we're selling here is $50, so that's gonna be the mean. That means that this is gonna be the center of this bell shape, right? And the standard deviation or the deviation, we don't know this yet. We'll just put something here. Let's put the number 5 in here for now. And maybe we don't want to go below $20, and maybe we don't want to go above $80. And that is the this base variables that we're gonna have. And the range of this is the maximum, minimum minus the minimum, basically saying that the price can span $60 in the edge cases, right? So that is that. And the next thing we want to do is generate this X column here, which is basically saying how the resolution is on the ticks on the X-axis here. So like, what is the resolution here? We're gonna need one value for each tick here, and that is what the X value is. So I'm gonna do this real simple. I'm gonna start with 0.01, and then 0.02. And then I'm just gonna take these two values here, and I'm gonna propagate it up until we reach the number 1. So we're like halfway there. Okay, too far. A little bit less. There it is. So the number 1, right? So we have these like evenly spread out, right? And the next thing that I want to do is, you can think of this as like percent. Like this is 0% here, and this is 100% here. Actually, we forgot the 0 here, so we need to take this down one cell like this, and then put the number 0 there. So now, there we go, from 0 to 100%. The next thing we want to do is we want to take this range that we have here and scale the percentage to that range, but we're going to start with the minimum. So what we need to do here is basically saying that we take the range value, and then we multiply it with this one here. We're gonna then add the minimum value. So basically saying that when we are at 0%, we have the min value. When we're at 100%, we have the max value, which is 80. And the thing is, like with Excel, this is, if you propagate this down, it's not gonna know that these are like constant. So the way you would do this is you would take this E2 cell here, and then you put a $sign there and the $sign there, and you need to do the same thing for this one here. But we don't do it for the K2 because that is going to propagate down. And hopefully, I don't know if we need to do one more. No, it seems to be working. All right, so we just take this and propagate it down to 100%. All right, so there we go. So like 80 is 100%, 50% is 50, and that seems to be working, right? All right, so the next thing we're going to do is we are going to generate the y-axis here. So like up here, what is the y value for each x value? And you know, practically in Excel we have this thingy which is called norm. So I mean, my Excel isn't Swedish, but this doesn't really matter. What you would do is that you would type norm norm dot dist, like this, dist. But for my translation it's this one. And then it needs 1, 2, 3, 4 values. So the first one is the x value, which is going to be given by this x column here. And then we put the semicolon there, and then we need the median, which is this value right here. But remember, this is also a constant. So what we need to do here is we also need to make sure to put dollar signs like this, because this doesn't propagate down. And then we put the standard deviation, which is this one. And we need to do, we need to do the same thing here. We also put the dollar sign like this. And for cumulative, we are gonna put false, like this. But in Swedish, this is translated like this. And actually, I did an error here. I see we're not gonna use the K column. We're gonna use the M column here. So like this, we're gonna use the scaled version of this, because otherwise the axis won't be correct. And that is all we need to do. This is scientific notation because the values were so small. Don't worry about that. It's because you can't really do the decimals into that many decimal places. All right, so here we have the probabilities. So now what we're gonna do is we're gonna take this. We're gonna take this column here, select all values, and we're gonna do insert, recommended diagrams, and you can already see here what we're aiming for. You can like play around with these like grouped columns and everything. I'm gonna go with a regular line diagram. Looks like this. All right, so now we're getting somewhere here. Let's give it a little bit more space, so we're using the full screen here. So this is really nice. So you would have this plot, right? You can see in the mean here, we have the mean 50 that we specified. And, you know, we have a bell shape like this. And if we give it a higher standard deviation, now is the interesting part. You can see we get a wider curve basically. And if you do a less, like a smaller deviation, like the number 2 or 3 or whatever, you get like a even more narrower like curve. And also like pay attention to the y-axis here. What happens, like if we make it a more narrow curve with a smaller deviation, that is going to mean that we're going to have a higher probability of ending up here. So the y-axis here is changing, so pay attention to this. So if I make like a wider, we're gonna get less probability, but this wider curve, so we're gonna spread the values out more. All right, so this is all fine and dandy, but like how does this actually like how does this translate? So remember this diagram here, like with the percentages, right? So we need to figure out the ranges for these values. So let's say that, let's go back here. We're gonna make something here we call standard deviation. And within one standard deviation, we're gonna have a mean and max value. Like this. And the minimum standard deviation is gonna be it's gonna be equal to the deviation, but the mean minus one standard deviation, right? And the maximum is going to be the same thing, but it's going to be like the mean, but plus one standard deviation, right? And what about what about 2 standard deviations? So we're going to have the mean, and then we're going to have minus 2 times whatever is in the deviation column, which is this value, and then the same thing for the maximum value, which is going to be the mean plus 2 times the standard deviation, and the same thing for 3 standard deviations. So for min here we have, this was just confusing. For mean for 3 standard deviations we have mean minus, and then 3 times the deviation, and for maximum the same thing, mean but plus 3 times the deviation. All right, so what does this mean? This is for 1 standard deviation, which means that we will have 34 on the negative side and also 34 on the positive side. So like, right, 34 times 1 for each side, so it's going to be times 2. So it's going to have 68.2. So you're going to have 68.2% of your data within this interval, right? All right, so what about the second standard deviation, which is like out here, so like 13 6, and then also for both positive and negative side, so you can have 27% of your data plus 68.2. So you're going to have 95% of your data within this interval. And what about 3 standard deviations? So in this case we have 2 times 1, which is this section and this section, so times 2. 4.2, and then plus 95 times 4, 99.6% of your data is going to be within 3 standard deviations. So 68% of your data is going to be in this interval, 95% of your data is going to be within this interval, and 99.6 data is going to be within this interval. So now you can start experimenting what this actually means. Like, if we give it a higher standard deviation, you can see that the interval here is getting crazy, and it's not afraid to go outside the boundaries that you have made, right? It's gonna go negative here on you. So you need to take care of that. Maybe you'll adjust the mean a little bit and move it a little bit to the right. You can see it moves to the right here. And maybe you want to have a more narrower. Then you can see also that this interval here is going to be much smaller in the range where you have almost all of your data. So like you're going to have 99% of your data within this interval, 95% with this interval, and so on. So you can see this is a way of elaborating with the data, you know, easier. You can move around the median in order to intuitively, you know, get a feel about how you can work with this, like to generate random numbers, right? So I hope you guys like this, and I suggest you follow along. And I hope, I mean, like the language thingy here didn't scare you off. And there is definitely like English alternative to this, so it should be about the same, right? So, and I think I covered all the translations. So I hope you guys liked this video, and don't forget to subscribe. That is really important. And leave a comment if you want to discuss something or something that's unclear. And I hope you liked it, and I will see you in some of my other videos, I guess. So right, so bye bye.